Hey, hey! Hello! Hello, welcome. Welcome to the stream. Welcome everyone. How are you doing? Hey, Photo. Welcome. How is everyone doing today? So there's my hair, a bit messy as always. This is what it is. Very accident prone today. Are you talking about the stream or yourself? Oh, otherwise doing good. Oh, but why is that? Well, it's good to hear that you're doing fine, so. So, welcome everyone. As always, new day, new stream. Today is Monday. Hope everyone is having a really good start of the week. And here we are again. We're going to start working on Voyager. Cut up my foot and scrapped my ribs in 2 separate falls. Oh my god. But what happened? Are you were you doing like something like a sport, or did it happen because you just fell to the ground, to the floor? Walking in the dark. Okay. Makes sense. Happens. Yeah, it happens. Okay. Might be stupid for continuing to do that, but... Well, if that's something you do because you like it, I don't know. So yeah, it could happen too when you like wake up in the middle of the night, you know, and you don't want to turn on the lights so you don't wake up everyone, I must say. So yeah, but maybe the context was a little different in your case. Okay, so what were we doing in the previous stream, which was on Saturday? It was a really good stream. We had a couple new follows. And in fact, I want to say thank you to Kilo and Nevo for the most recent follows. Thank you very much, guys. And yeah, so let me go through really quick what we were doing. What we did last stream, okay? So this is my planner thing, okay? And this is what we have, okay? Like the tasks are already work in progress, but we are working on the planetary system map, okay? So let me show you really quick how that is working right now. So the planetary system map is basically a mini map that lets you see like the position of the planets and your position inside like the planetary system. So when you're in your starship out in space, okay, you are going to have this mini map so that you can know where you're going to, and so you can easily navigate in space, okay? So if you want to go to any planet, you can do so by just checking this and checking your position, and yeah, so basically like how any minimap works. So yeah, we have the basic navigation for the starship. We have been improving a little bit all of the rotation sprites. That's something we did too. They are not amazing, but yeah, they're decent for now, I think. There are a couple of the rotation sprites that I think need some work. For example, this one, like in between those two rotations, the middle one, this one, looks a bit off. So yeah. But anyways, that's something we were doing in the previous week and the week before that, I think. And the last couple streams we were working on this minimap, okay? And what we have right now, you can see like first of all, stars, like planetary systems, can have between 1 and 4 planets, okay? And the idea is that they have like a position in the orbit, okay? So they are not like placed randomly in space. They have basically an orbit, and they are going to be positioned relative to their orbit, okay? So that means that that basically when the star gets created procedurally, then it decides, okay, it's going to have X amount of planets, and those planets will determine their position in the orbit, okay? So we did that by basically using a formula that lets us set the position of the planet by simply saying, okay, so we have just one value that goes from 0 to 1. It's like a percentage, and we can say, okay, 0% is this position, okay, all the way to the right. And then all of the values in between 0 and 1 are basically the positions along the orbit, okay? And that's pretty much working. And what you're seeing now is all of the planets that are randomly positioned in their corresponding orbit, okay? So in the case of this star has 4 planets, and once I hit play, the game is going to create like a random star so that we can test, and then it's going to determine how many planets it has, and then the position of the planets. And every time I hit play, like I restart the session, it is going to create a new set of planets with like a unique position, and in essence is basically creating a new star every time I hit play. So we're not getting the same star all the time. It's basically a new star so that we can test like different cases every time. Okay, so that's pretty good. You can already see that the planets are being positioned in the orbit randomly, and that's pretty good. So that's one thing we were working on. That's already working. Okay, yay! Random generation, PCG, yeah. So that's pretty good. And another thing we were doing was this. Let me open up my sketching, my boards. Okay, my boards for the actual concepting and that sort of thing. So, okay, so we have here a lot of things, okay, but this is what we did. This is specifically what we worked on in the previous stream, okay? So this was basically for setting, maths. We were like having some issues with this because the formula I was using was not entirely accurate, so I had to adjust some stuff, but now it's working perfectly. And this is pretty good because I'm using the same philosophy I was using for the constellations. So let me first show you the constellation thing I'm talking about, okay? So constellations contain a set amount of stars, okay? So constellation is basically this, okay? It has a number of stars and they are connected between each other, okay? That's a constellation basically. Now, the constellation system is pretty much, the basic part of it is pretty much done. And one of the things we did to generate the constellation procedurally, we basically set a fixed minimum and maximum amount of stars that a constellation can have. Okay, that's just an arbitrary number I set because I like this for the, I don't know, because how the balancing feels. Okay, so the minimum amount of stars is going to be 3, and then the maximum is going to be 7. Okay, exactly 3 to 7. And what does this graphic mean? This is basically a star count probability distribution. So this is basically a curve that determines this is a curve that determines how common is going to be each kind of constellation. So as you can see here, probability is the vertical axis, normal distribution. So yeah, kind of, because its probability goes from 0 to 1, it's like from 0 to 100, it's a percent. So yeah, we could call it normal distribution. So horizontal axis is basically the amount, and with this we're defining that 3 and 7 star constellations are going to be the most uncommon ones. Okay, so you're most likely to find 4, 5, and 6 star constellations. Okay, and then 3-star constellations and the 7-star constellations are going to be rare. And right now there's nothing like defined for why this is like this, and what happens when you find like a 3-star constellation. This is just something arbitrary that I defined because I wanted to. There's no further explanation, but like this is pretty good because although the generation of the constellations is completely random, procedural, this gives us a little bit of control of how things are generated. Okay, so we now have some level of control of, okay, so yeah, I want like constellations of 5 stars to be the most common one. So in every playthrough there's going to be like, I don't know, maybe 80 or 70% of constellations are going to be 5-star constellations. Okay, so that gives me a new resource that I can use for design. So I can say, okay, so if you find, like, if I'm talking about like some kind of mechanic or something for the future, I could say, okay, so if you find like a 3-star constellation, then those constellations contain the most, I don't know, beautiful planets. I don't know. Hey Ciala, what's up? How you doing? Take my money. So we're using this same philosophy or this same like formula to also define how many planets a star can have. Okay, that's the idea. We're using the same concept so that we have some level of control over how many planets are in each star. Okay, so in this case, you can see that the curve is a little bit different. It's not a sine curve. I ended up using like an expo curve, which is like much more like, I don't know the word, but it's like steep is the word? I don't know. So in this case, you can see that a star can have between 1 and 4 planets. That's the maximum for now because I wanted to set it that way. Maybe in the future I can make it be like more planets, but for now I think this is a good number. And in the future I plan to have moons for planets, so maybe a planet can have between 0 and 2 moons, for example. So then you can kind of count moons as other planets because you can land on them and explore them. And okay, negative moons. So a planet can have like a -1 moon, and that means that it has like a black hole inside the planet. So when you land in the planet, you get sucked on the black Saturn with its 100 plus moons enter the chat. That's true, we're not being accurate with real world. We're setting some strict limits here. So yeah, that's the idea. Although it's a really interesting thing to think about. Okay, what happens if a planet has -1 moon? I don't know. We could ask the ChatGPT to know to see what it thinks about that. That could be a really fun experiment. So in this case, as you can see, I want stars to be more likely to have between 3 and 4 planets. So yeah, in this case, for example, it's going to be really uncommon to find stars that have 1 or 2 planets, and that's really cool too, because maybe I could say, okay, if you go to a star and it has only 1 planet, then that's like an abandoned star, and the planet it's all corrupted, for example, or something like that. I don't know, something interesting, and I think it could be a good thing to add to the game. The AI asked if I was referencing the brilliantly dark and sexy music that gets into your bloodstream and stays there. What the hell? That's some crazy stuff. Brilliantly and dark and sexy music that gets into your bloodstream and stays there. That's a really interesting concept. I don't know, now I want to hear that kind of music. Maybe that's what happens. If a planet has like -1 moon, then when you land in the planet, you can hear that kind of music all the time. I don't know. Interesting. So that's great. That's what we did in the previous stream, and that's pretty much working. I spent like a bit more time that I would have liked on that, but I know that now it is correctly working, so that's pretty good because I have this function that I can use everywhere. So basically I can pass in like a minimum, a maximum, a curve to use for the probability distribution, and that's it. So I can ask for like a random number, but with like a curve that represents the probability between all of those numbers. Because time is money. How much each moon will cost us? Oh, I don't know. If the moon is like a negative moon, maybe I have to pay you to go to that moon. That doesn't sound fun, does it? Do you have astronomically correct moving orbits? No, but we were talking about that. We were talking about that because it's something interesting, and this is the thing. This is the thing that I was I don't know the word, but anyways, can you imagine such orbits? We will be able to find planet X. Oh yeah. So maybe in the future. Yeah, so yeah. So you're talking about like astronomically correct moving orbits, but not planets, orbits. So that's a different thing. I just realized. So if you were talking about like astronomically correct moving planets, I think I wouldn't be able to run this on my machine. It's going to be a simulation so heavy that I don't know. Realistic orbits are exceptionally expensive. Yeah, that's what I was thinking about. So yeah. But if you were asking about like planets that that actually orbit around the star, okay, so for example this. Now this is something that's possible and shouldn't be like really hard to do. In fact, it's not hard to do, but we were talking about something that could be a bit annoying to some players. So imagine this. Imagine you go, this is your starship, okay? And you go here to this planet. And you say, okay, so this planet is pretty close to this one. In fact, let's move this one here, okay, for a moment. So those two are pretty close. So you say, okay, my plan is going here and exploring and blah, blah, blah. And then when I finish, I go to this one because it's really close. So I don't have to spend a lot of fuel, because that's one thing in the game. You need fuel to travel in hyperspeed, okay? But if we make the planets orbit around the star, like actually move around the star over time, which is what happens in real life, that means that maybe when you finish exploring this planet, maybe this one moved here and this one moved like all the way here. I can't even like crop this. So maybe this one moved like here and this one moved here. So now it's not really close, is it? So that's the thing with like actually like orbiting planets. And maybe that's for some for some players that could be something interesting and fun and immersive, but for other players maybe that could be a bit annoying. So I don't know. I would like to experiment with this in the future, but yeah, for now I'm just setting the planets to a fixed position in the orbit and that's it. Well, I never said physically accurate, just that they have a fixed path. Yeah, that's kind of what's happening. Also passing the star, so not going to be simple to get to. What do you mean by passing the star? Do you mean that you're like traveling, like navigating through the star like this? This is like not a problem, because in the Bath example you had was going through the star. Oh yeah, but in reality the star is just a decoration thing. It's not going to affect anything. It's just a thing that's really far away. In reality you're not going through it. You can go like and see it like it's in a really far plane in the background. So that's the thing. In fact, the planets are also going to be in a really far plane in the background. That's why when you get close to a planet, you're going to see it moving really slowly in relation to the other things that are in the in-between layers. So that's just to give like a really nice parallax effect and to give the impression that the planet is far away, but you're like in the orbit of this planet. So you're orbiting the planet and then you can land on it. So if I show you this in the game, for example, you can see that there are like several layers, and I have like these red stars that are placeholders right now. This is not going to be final, of course. This is just to demonstrate some stuff and to test. But basically you can see that if I navigate, I think the planet is close somewhere around here, I think. Is it? Yeah. So when I get to the planet here, you can see that the planet is in like a background layer. So I can go like through the planet, but you understand from the perspective that between the planet and the starship there's like a big space in between, but the camera is like fixed on the starship, so the perspective looks like this. So yeah, but we also talked about something that was really interesting. That was this. Let me show you something. And this was really interesting. So imagine that we have like a planet that's like this big. So now it feels like you're really close to the planet, and that also looks really cool. Yeah, so it's huge. Now, one thing with this is that I would need to like, you can see like the border of the sprites has like really big pixels because it's just scaled. Yeah, the pixelation is not looking great here. And also maybe the shader itself, it's like lacking some finer detail. You can see that now it's like the same sprite, but it's stretched, is nothing else. But what I would like is that the actual shader of the terrain of the planet and everything has a lot more finer detail. Vector maps for art. What's happening is the planet is entirely being generated with a shader. So I'm not actually drawing any planets. I don't have like any planet that's hand drawn. This is all being made by shaders, basically. So I can show you really quick here. For example, yeah, I can't use vector maps, but if you see here, for example, it doesn't matter how much I scale the planet, the shader is going to render with no, like, if it is like a vector, basically, because it doesn't have like a resolution. So yeah. So I don't need to worry about the resolution of the actual stuff that's happening in the shader. But for example, what I could do is like, I don't know, maybe do something like this. I'm basically clamped this, but I don't know. You can see I can do pretty crazy stuff with this. It's pretty fun. So yeah, maybe like, I don't know. Yeah, but I will explain what's happening with the pixelation. This is not actual pixelation. What I'm using is just a circle sprite that I did in Sprite that I exported, okay? So this is an actual exported sprite, which is just a white circle, and then I am applying all the shader in that white circle. And the white circle has like a fixed pixel resolution, and when I scale it, the pixels are going to be bigger because I'm basically scaling a sprite. So that's what's happening. So you can see here, I have like, yeah. So this is dumb. I shouldn't do this because what I'm doing in reality is basically for this doesn't look pixelated right now because in this scene, the pixelating system is not working right now. I can show you really quick. If I go to, oh yeah, and this is going to be fucked up right now, but it doesn't matter. So if I go to the planet scene, let me show you really quick. In the planet scene, the pixelator system, it's a system I did so that it grabs stuff from the scene and pixelates it, okay? Because the game is not pixel perfect. That's because I want a smooth camera movement for the parallax and all that kind of things. But if I hit play here, you can see that everything is broken. Okay, it didn't work. Oh my god, what happened? Let me see if I can fix it really quick. Set properties. I don't think I can fix it right now. But yeah, maybe I have a video somewhere. Yeah, that's because I'm changing a lot of things in this scene, but I'm changing systems that are being used everywhere, and I have to refactor a lot of things. But I think I have a video somewhere that I can show you really quick how the actual planet looks like in the background in the planet scene. So yeah, I have a video here. So this, for example, you can see here like the planet and the clouds are actually pixelated. I don't know if you can tell in the little screen, and I also don't know if I can scale it more than this, but gonna have to lurk anyway, gotta get some work done. Okay, yeah, no problem. So yeah, basically I wanted to show you this, that basically the planet gets pixelated, and using an actual circle sprite that already pixelated doesn't make any sense because I'm already pixelating it afterwards. So yeah, anyways, that was my point. So yeah, okay, anyways, back to the thing. Now, what we were doing was basically that we have the... Actually, let me go into fork and I'm going to undo the material changes I did. Planet material, where is it? Here. Okay, so undo. It's great. Okay, perfect. So I should also push, I think. But I'm going to push. I don't know. Yeah, anyways. So, what we have a couple tasks we want to do. Okay. Next, so we already have the planet positioning around the orbit working, so that's perfect. But we also have something that's that we need to fix, which is the Y position of the planets in the thing should determine the sorting position. Okay, so that should be a really easy fix, I think. So let me go. Oh yeah, I need to create a new script for this. So here in orbits, I basically need like a script that controls all of the orbits. Okay. So I think I can just go here and just create a script that's called UI orbits handler or something like that. That's good. Okay, so I'm going to fix a little bit my camera like that, I think. Okay. So, so that's one of the tasks we have here. Sort planet sprites according to their Y position. Okay. That's because I'm going to show you really quick what's the issue here. You can see that we have the orbits and we have the planets, and here you can see that this orbit is overlapping with the planet and it's on top of the planet. Okay, so what should really happen here is that each planet should be sorted. Like, first of all, they should be all like outside of this object because of how Unity UI works. So now they are not going to be ever behind the actual orbit sprite, okay, the lines. But also there's something that happens when planets are like overlapping, and now they are pretty much the same color. So like, I don't think this is a big issue, although that looks like a big blob, and maybe that's not good. But like, there's a couple solutions I could use. One of them is setting like a different color to the planets, so a different shade of blue. That could work. So for example, the planets, like the higher they are, the darkest they are. Okay, so that's something I could do also, but first I want to try doing this. So let me just say UI orbits handler. So I'm going to say UI orbits, and I'm going to go here, and I'm going to say UI orbits handler. Okay, so, and also this should be inside this namespace. Everything is inside this namespace. Okay, great. So now what I should do is basically have a reference. Okay, of the orbits. I should have, oh my god, I hate when Unity does that. I want to create this called init, and it auto completes with this crap. I don't want that. Okay. So so now I have UI orbits, okay? So what's the thing with this? Here I should receive basically a list of the planets, of the actual planets. And here you can say that I'm like initializing all of the things. And I shouldn't do that here. I should simply say, like here, instead of having this, I should have a reference to this, and now I'm going to say basically orbits handler.init. But now I should basically like have a reference to the planets, okay? So this is basically a list of planets. So this is going to be list planets, planet.properties. Okay, and here I just need to say that, and here I just need to do that. Okay, now that's the same code basically, but now it's handled in the correct place. Okay, so now I just pass through the reference to the list of the planets and then initialize the orbits inside the script. Now, I should also set the actual like position. So like depending of the Y position of like all of the orbits, of the planets in the orbits, I have to set them so that the highest the Y value of the position is, the further back in the sorting order that planet is. And here I should have like another reference to the parent of the planet images, okay? So I have this planet's pivot, or I can say planet's parent, and then this is a bit yucky, but so after I initialize them, I'm going to go through again the orbits, okay, and I'm going to basically just set the Y position of the planet itself. So now what should happen, I should have like some kind of function here, and to delete those libraries because I'm not using them. I'm going to also delete this, and I'm going to, or I'm not going to delete that because maybe I'm going to use that. And then here I should have some kind of like function here, public void set planet sorting order, okay? So yeah, I don't really know how I should yeah, let's first have, I have the planet image reference. And what else do I have here? So I have the actual position. Oh yeah, I need to return the actual position there. Hey Lou, how you doing? Hello, welcome. So, so yeah, I'm thinking that. Give me one moment. Okay, so I'm thinking something that I should do, which is just go through again So I need to think how I can do this, because I basically need to set their order as siblings, okay, to those objects, to the planet image, which is an object, and depending on their position here in the hierarchy, it's going to be if they're like in front or behind. So first of all, I should have like a thing called planets. Planet IMGs. Now I should have this here, then I should have a reference to all of this. Then I should also change the reference to this here. It's perfect. So now I will basically be changing this to be parented by this, and then I have to change the order of their thing, okay? So anyways, I'm not going to do the in fact, you know what? I'm just going to set the position right now. I'm going to do this really quickly. I'm not going to bother too much because it's something secondary and I shouldn't waste a lot of time on this. So basically, I should go here and say orbits I dot planet img dot rect transform dot set parent planet's parent. Okay, that's all I need to do. That's going to just grab the image and set it to the new parent so that they're above everything. Okay, that's the idea. Okay, so that's pretty much it. I think that should work. Okay. Okay, that's perfect. So now I can basically hit play, and every time all of the planets should be on top of the orbit lines. Okay, that's the idea. You can see that it's working. Now there's something that I don't really like, and that's the star being on top of the planets. I think it should not be the case. That shouldn't be the case. So that's really easy to fix. I think I only need to just move this here, and that's it. In fact, I think I could also put it like behind the actual orbits. Is it working? Yeah, I think it is. Yeah, it is. So yeah, I think that's pretty good. And also, you know what could be great? I'm going to disable this. Well, let's hit play and let's check something, because I think maybe the star sprite could be like a smaller one and it could look really good, because I set the biggest size of the star. I have like different sprites for all the sizes, and I think maybe I should set it to the not the smallest one, but maybe like this one. Yeah, I think that's much better. And even maybe the number 2. I think that's too small. So maybe, yeah, maybe I'm just going to use the size number 3 for this, because this is just representative of like, just so you know that the star is in the center and then the orbits are around and blah blah blah. Okay, that's the idea. So I'm just going to grab this and change the actual sprite so that it is the number 3. Okay. Now there's another problem with this, and that is that this, like the sprites are made in such a way that I cannot assign the color via multiplication like this, because it looks really weird. Okay, so if I set it to that, or for example I set it to something dark, the star is going to be really dark, and that doesn't make sense. Well, it could make sense if you imagine something blah blah blah, but I want them to look bright, okay, because they emit light, so they should look really bright. But what's the thing? For the other stars, I'm doing that with a shader, and I'm setting the color additively. So that means that, and this is setting the color via multiplication, okay? And when you multiply, the darkest color are going to remain, and when you add the color, it's going to increase the value, okay? So that's what's happening with the stars. And basically that's not great, okay? Because what I really want is for them to be additively set for the colors, okay? Because here I want to have the actual color of the stars, and because so you know, so that you know like the actual color of the star you are on, because the color of the star is important. You should know, like, some properties of the star are going to be affected of depending on what color it has, basically. So yeah, another thing I could do is just set it to like a fixed color, for example like blue, and that's going to be like, I don't know, maybe that's going to be maybe that's not that bad, because I don't know, let me just hit play and see how it looks like that. I don't know. It could be that color, or it could also be that color. Yeah, there you can barely notice it, and the 4 like black pixels there are really evident, and I don't really like that. In the blue version, it's like a bit more noticeable, and I think that maybe that goes a bit better with the overall like aesthetic of the little minimap. I hate color theory. Yeah, it can be a bit annoying, but it's so silly. Yeah, it's like once you understand like the basics of like what makes things stand out is contrast, and contrast can be achieved by using complementary colors. That's like the most basic thing, and that works every time. So of course there's a lot of depth in like color theory, but like I'm not an expert by any means, but like I like using the tools that color theory gives you to compose stuff, basically. So yeah, here you can see that this panel has like, it's not monochromatic, but it's like using like a limited amount of colors, and you can see those colors are repeating everywhere, so that it feels like a consistent thing. It's coherent, basically. That's what I'm trying to say. And it doesn't need to be like that. I could use more colors here. This is just a stylistic choice I'm making. So you can see here I'm using like basically just pink, purple and blue. That's it. So maybe that's just enough for now. we could change it so that planets reflect the actual color of the planet, like the main color, and also the star reflects the same, like the actual color of the star, because stars can be like blue and purple and yellow and green and blah, and depending on the color, they are going to have different properties. So yeah, that's one thing basically, and I think that may be important, but I don't know. I was also thinking that, and I think I even implemented this before, but now everything is different, but the actual space background that you can see here, so you can navigate blah blah blah, and you can see that the space background is all black, like in grayscale. But I did it so the actual space background is going to be the color of the star. So if the star is green, the space background is going to be like a dark green. And I think that's pretty good because it gives you like a really easy way of like knowing which kind of star you are on. Like it's the most evident thing you can think of. And it wasn't bad because it also adds like variation to the like to the visuals, because if I make the space background every time black in every star, that's going to get like too repetitive. But yeah, anyways, I think we solved the Y sorting. Like, it's not actually the Y sorting. We basically made the planets not be anymore like behind the orbit lines anymore, so that's fixed. So now I'm basically going to move this one because it's not quite the thing we just did, but I'm going to move that into its own task in this list. Okay, so that's something I may want to do in the future. So I'm just going to set it there. Oh, I didn't want to do that. What the hell? I tried to copy this. Why did it copy another thing? I don't know. So here, planetary system. Let's. Oh, I know why. It's because I press Control Z instead of Control D. Oh my god. Okay, let's go again. So here is Control D to duplicate the task thing, and now I paste this. Okay, so now I have that task there. That's great. And now this is the thing we're going to do right now, which is track player's position. Okay, so as you can see here, there's no thing that represents your actual position here. So how the hell do we do that? I have no idea. Now I have some like an idea of how I can do that, and there's a good amount of things involved in making this. So so yeah, for now I'm just going to do something really like hard-coded and whatever, but this is basically going to be setting the position of the starship randomly. Okay, I'm going to set it randomly. Okay, and I'm going to say just new vector 2, and I'm going to say, I don't know, and here I can use random range. For everything that's random, I'm using Lemur, which is a system I like. It's a library, it's a system created by some person, and that's really good. But that's I'm using Lemur for like sequential callings of like random numbers, because when you use a seed, the Lemur system basically gives you the same random numbers. Like the sequence is always the same. The numbers are random, and you don't know what's going to be next. Okay, but if you use the same seed and like recreate the same sequence of callings of random numbers, you're going to get the same random numbers every time. And that's pretty good, because if you were to start like a new game, like a new universe, and use the same seed every time, that means that you're going to get like the same things generated if you follow the same steps you did. That's something really fun. So whatever. So basically now I'm going to say random range between, I don't know. I also need to set like some kind of boundaries. So maybe you should like appear close to something. I don't know, maybe I can refine this in the future, but right now I'm just going to say random between -50 and 50. I also have to say set set to a random position, and I'm going to say bounds equals 50. So now I can say bounds, and okay, so that's great. And here I could also say vector2 random pos of x is going to be that, and random pos of y is going to be also that. So I can just say random pos here, and that's much easier. Okay. Okay. Okay, great. So that's going to just, whenever I hit play, this is going to just set the position of the starship randomly, whatever. So what do I want here? I want 0, 0, okay, the center of the scene, to be the position of the star. And for that, I need to have the actual star in the scene, and that's something I don't have, okay? So, so for that, I'm going to use, I have a sprite, okay? I don't know if I have a prefab for that. I have this is called Sol, which means sun, or like the sun, and this is sun in Spanish, okay? Which is my main language. But the thing is, this is a prefab that I'm using in the planet scene, because it's for the actual like sun, or like the star that's moving like in the cycle and everything. So I can't really use this in this other scene, because it shouldn't move at all. It should be in like 0, 0, and that's it. So so basically I'm just going to create a new thing, okay? I'm going to create a new sprite, and I can just copy this, and I can just unpack this and call it like star. But this is not the star. This is basically well, this is a star. But I don't know. I think I would need to refactor this so that I can actually use this Sol prefab, because it would be the best thing to do, I think. camera parallax object. So why does it have this? I'm doing that here, so it shouldn't have this thing. So I'm going to remove it. Then container, sprite, light. Okay. So you know what? I'm going to use it here. Whatever. I don't care. I'm just going to. It looks really cool. So this is on 0, 0, but the actual container is not on 0, 0. And I should set it to 0, 0 here. Okay. That's good. And now it looks like the starship is exploding. So let's see what is here in the Sol object. So we have the light, it has a container, it has a reference to the planet, which is a bit yucky. Planet, where is it using the actual planet thing? Planet properties, sky properties, that's Sol azimuth. Okay. Yeah, this is not great. So yeah, I should handle this differently because it shouldn't be getting like stuff directly from the planet. It should instead access the actual planet that we are on when you are in the planet scene. So when you're actually in a planet, it should be getting information from the planet, but it shouldn't be this way. Update solar cycle. This is something that shouldn't be happening unless we are again in a planet. Question: shaders use 32-bit floats. If we use a map too big, the ship is for example 14,000, the accuracy of float numbers would make the ship jump around. Yeah, I think that's correct. And for that, I was thinking about this previously. So like last week, I was actually thinking about that. And let me show you something that I noted, like I written in a task for this. So this is something I set as a task that I will do at some point. When you get to the end of the space, okay, you look back to the other side. So this is essentially the same mechanic that asteroids have, where if you get to the boundaries of the actual scene, and that's just a number I can set, okay? So let's say this is the boundaries, okay? I set the boundaries to be 1,000 in the x-axis total, and then 1,000 in the y-axis total. What would happen is if you go and then, like, for example, if you go vertically infinitely, if you surpass the boundaries, you're going to loop back to the bottom, and same way, like vice versa. And also the same is going to happen in the x-axis. So essentially this is going to happen, okay? You loop back to whatever axis you're going through. Yeah, exactly. Space is not infinite because it doesn't make any sense to make it infinite, because why would I make it actually infinite? It would basically break the game if you navigate like infinitely into one direction. And in fact, I did watch a video of like that same thing in No Man's Sky. So I searched for like a video that said like I don't know, the guy was just basically in the starship and it started like going infinitely into one direction, and at some point, like, I don't know, maybe after 1 hour or something like that, the game started like bugging, and everything started like bugging out. And I don't know, it's like, it doesn't make any sense. I don't want the player to start going infinitely into one direction, because there's nothing for the player to do there. And also, you cannot save the game like in whatever position you are. You need to go to certain places or certain like consoles or terminals to save the game. So it's impossible to break the game that way too. Even if you go like infinitely, let's say I don't do the looping thing. If you decide to go infinitely, like really far away, you cannot break the game, because you can just close the game and open up again, and you're going to be in the previous save point. So yeah, that's basically it. And I think like, yeah, that's another thing. When you're in space, you can navigate freely and blah blah blah, but you cannot like save the game while you're in space. So you have to land somewhere to save the game. So I'm just going to to use the same mechanic that No Man's Sky uses, so that you can't just save the game in space. You have to go to I don't know, maybe a space station or like a planet or somewhere, but you cannot save the game like here in this spot, and when you close the game and open the game again, you're going to be here. No, you're going to be at your last save point. That could be a space station, or maybe like a floating island in space, or like an asteroid that you landed on, or like a, I don't know, a planet. So yeah, basically you don't want to close the game while you're in space before saving, because you're going to lose the progress. That's the philosophy I'm going to use, unless I come up with a better idea or something interesting or cool. But for now, that's how I think about it, and that's going to prevent stuff like that from happening. So yeah. Okay. Yeah, it should work. It should work. So if we face more problems, I have idea. That's great. That's great. I always appreciate your ideas. So that's amazing. So here we have the soul. I called it soul. I don't know. So now what do we need for this? Right now, I think I could just leave it there for now. It is just going to, in fact, I'm going to disable that so that it doesn't do the actual logic, because the logic is only going to work in the planet and not here. So now I only want it to be here, so that we have the reference of where the center is, okay? And this is going to be in like a further layer than the planets. Planets are in the layer number 3, and the soul is going to be in the layer number 4. So that means that when you go through like near a planet and you also are seeing the star, it's going to move at different rates, and it's going to look like the star is really far away. And I think that's going to look really cool. So yeah. Okay, so I'm going to drink a little bit of water. Okay, so So let's hit play and let's see what happens. Now what should happen is the starship should get into a random position, Okay, let's see. Okay, it did go into a random position. That's good. And it happens to be that the position is really close to the actual star. Oh, it looks really cool. It looks really cool. But I think, yeah, you know what? I think it should be even farther away. Let's see what happens if I go into hyperspeed. Oh yeah, it moves really fast. So I think it should go a lot lower. So maybe instead of here, it could be in layer number 6, maybe. Yeah, in the same layer as the space vacuum. And for this, I want to see which sorting layer. -5, okay. So this should be sky -5 too. Okay, that's perfect. And this target sorting layer, sky, okay, that's pretty good. So now, if I hit play again, we should see like this little square here move into a random position. Let's hit play, okay. Okay, it did move to a random position. In fact, we can check this and it's on 23 and 3. Now, it is right on top of the star. And yeah, I don't know if that's good because it's, I don't know, it's, yeah, I like the rate that it's moving there, but I think maybe it should go to the next layer. I don't think I like it being there, because it means that when you're moving in the normal speed, it's going to be like right on, like behind the starship sprite, and that it doesn't look really good, because you can't move the camera around. It's going to be fixed. So yeah, maybe I should move it here, and let's see which layer is this. -3. Okay. So this, I think I could leave it in the same sorting layer, so it's going to be, well, I should put it in -4, in fact, -4. So it's in between the space background, like the vacuum, which is the texture, like the dark texture for space, in between that and the first layer of stars. That's good. So yeah. Okay, let's see how it looks like, and it should be good. Should be fine. Let's hit play here and see how it looks. Okay, so I'm in basically minus I don't know how many numbers. -32 and -26. Okay, so that's fine. Now we can see that the star is moving like a better rate, I would say. Yeah, that's pretty good. So I like it right now, how it looks. So yeah. So yeah, now okay, so now the next step, so this is fine, this is mostly fine. Now the next step is to basically try to track the actual position of the starship, and for that I think I need to define the actual boundaries of the space of this thing. Okay, And the boundaries are going to be like with this aspect ratio. So that's going to be, I think, this is going to be 16 by 9, which is the aspect ratio of the of this panel. You can see it's rectangular, like the monitors nowadays. So, now there's one thing I would like to know with this, and I have set this. So this has like an aspect ratio, okay? And the thing is, I would like to know, since I'm really bad at math, I would like to know what aspect ratio is this. Now, I don't want to base the actual boundaries of the space on the size of this panel, but this should be approximate at least. So I think what I could do is basically use like, maybe I could use actually like the yeah, so let's do this. Okay, let me just go here. Let me hit play first here. Okay. And okay, let's say let's move the starship to the position 0. Okay, 0 0. Okay. So now for the starship, let's look up the tables. And here in planetary system is not that, is here. So here, this is the relative multiplier of like, well, like it says here, it says values for getting the relative position of the background object according to its background layer, okay? To calculate, it will be the example, it will be, for example, background object dot position multiplied by this value, okay? So how do we know the actual position of the planet right now, like in normal units? Because as you can see here, background planes have their own like units for positioning things. So you can see here, this planet is on 4 4, okay? For XY is 4 in X and 4 in Y. But if I move the starship to 4 4, you can see that the planet is not like the starship is not in the same position. That's because like they move at a different rate, and I have to like calculate the relation between both planes. Okay, and the relation between both planes is basically this position multiplied by the set position of this layer, which is 24, divided by 2. So in reality, this is in the position, this would be 4 multiplied by 12, okay, which is 48. So if I move the starship to 48 and 48, you can see now I'm exactly on top of the planet, okay? That's pretty good. And that means that this could be, for example, a planet that's really close, okay, to the star. Or not. I think it should be like the closest orbit should be that one, okay? So that's basically the relation between the first orbit and the star. So now, based on that, I want to set the actual boundaries of the of the complete space. So let's say, for example, we use like relative numbers. So for example, the second planet is going to be in 8, for example. I don't know. Maybe it could be in 10. So that means that it would be, it's going to be 10 multiplied by 12, it's going to be 120. So for you to get to that planet, okay, you would need to go there at like a hyper speed. Maybe this is still too close. Yeah, because you get really fast. You get really fast there. So maybe I should use like bigger numbers. So yeah, I should calculate actually how much it gets, how much time it takes to get to a certain distance. So yeah, let me just move this to 0, 0, okay, and let's go like let me see if I can just set the current angle to 0. I think I can't because it's like not an exposed variable. That's a shame. Yeah, I don't think I can do that. But we can do like an approximate. So now it is pretty much moving like mostly in the x-axis and almost nothing in the y-axis. So yeah, let's okay, it's going to keep moving. If I freeze this, okay, now I can set it to 0, 0. Now let's see this. So if I go let's accelerate in the normal speed. So yeah, it is not oh yeah, it's really annoying. How can I do this? So yeah, I can just use like an approximate. I need to calculate how much time it takes to get to a certain position, and for that I need to actually know the exact velocity, and I actually know the exact velocity, but I don't know if that's related to angular velocity, linear velocity. So the velocity is going to be basically yeah. So velocity is going to be the max thrust divided by 2. Okay, if we're going to if you set the max velocity only in the x-axis, it's going to be this divided by 2. And I think that means that you're going at a speed of, for example, 2.5 units per second. I think that's what it means. So let's try to let me do something here. I want to go into this thing. I can close this, and I can go here, and I should be able to here, instead of doing that, I'm just going to set it to 0. Okay, Can you reformulate the problem? Magnitude of the velocity vector? Yeah. So, do you want me to repeat what's the actual problem I'm trying to solve? So basically what's happening is I need to calculate how much time it takes to get from point A to point B. So yeah, that's easy because it's basically just saying, okay, velocity is going to give you one part of the equation, okay? So I'm trying to confirm something here. So now the actual angle of the starship is 0, and I should be like state fixed update. So let me do something here. I want to try something first because yeah, that's what I need to know. Before setting the actual boundaries of the space, so if I define the boundaries of the space, so like how big is this in like world units, okay? I need to first define that before saying, okay, so the furthest orbit is going to be in X radius, okay? Then this orbit is going to be another radius, and then this one is going to be another radius. So then I can use the same formula to actually set the position of the planet in the orbit, but in world space. Okay, so that I can say, okay, so the furthest orbit is at the radius of, for example, we can say, I don't know, just to set a number, 500. Okay, so 500 world units. So that means that this planet is going to be 500 units away from the star. Okay, and I should also not use like the radius like the way it is, because the radius is for like perfect circles, okay? But here I'm using like ellipses, which have like a flattened circle shape. I'm deviating a bit from the problem here, but it's all related. So when I set the actual boundaries of this, and I set the actual radius of the orbits, then so in order to be able to set the actual size of the space in world units, I want to know, why don't you put a constant somewhere for the ratio? So that's the thing. I want to first know how much time it takes to get to a certain position. So then I can say, okay, I want the player to be from the center of the space to that position. I want the player to take like, I don't know, maybe 30 seconds. Okay, so that's basically what I want, and that's because I want to balance the distance between the planets, and so that everything is like at a coherent distance. 30 seconds multiplied by velocity is the distance. Exactly, yeah. So that's what I'm just about to do, and that's why I basically was coding this. If B is less than 1, what is A and what is B in this context? So what I'm trying to do is basically I'm going to do this. If AB is less than 1. Oh yeah, the constants. Yeah. Okay, so So I want to use the radius, but like using the ellipsis formula. The ellipse, not ellipsis, the ellipse formula. Okay. Anyways, here I want to basically just measure time. So I'm just going to do that. Okay. So for that, I'm going to just do this, and I'm going to say then your ratio constant should be velocity multiplied by time itself, 5 by multiplied by 30 seconds. The ratio yeah, I don't know if I understand that, but I think what I'm going to do is basically what you're describing. So let me check this. So yeah, I think I understand now. So I should basically do the formula. So if the speed, that's what I wanted to check. So let me first say this. Okay, so I'm going to see how much time it takes to get to 10. Okay, this is basically just to check, and it should take 4 seconds because the actual speed is 2.5. That's the actual speed in the normal thrusting. But I want to confirm if the velocity in Unity, because like I have the actual velocity information here and I know what the velocity is, but I want to know what it actually represents, because they are just numbers, and I want to confirm if that, for example, if I say a linear velocity where x is 2.5, that should mean that 2.5 is like the amount of distance that's traveled in 1 second. I think that's the formula for velocity is distance over time. Okay, and I think they are measuring this in seconds. So yeah, I'm basically going to check this now. So I'm going to do this. Okay, so now I should be able to see here seconds is 2. Is it correct? Well, it doesn't matter, because now I know that it takes 2 seconds to travel 10 units. Okay, so that means that the actual velocity is 5, I think. So where did I set the thing? Let me just go here. Acceleration, max thrust. The limit, because I'm limiting the velocity. Max thrust, no, is 5. Yeah, it's 5. So max thrust is 5, and here I'm limiting the velocity magnitude with this variable, and this variable is basically max thrust divided by linear damping. Okay, so that's the linear damping is something I'm using so that when you stop accelerating, the starship slows down, like decelerates, instead of like stopping dead end, it basically decelerates, so it feels more like there's inertia and that kind of thing. But this thrust limit, did I stop it? No. So thrust limit, if I go here, it should be 2.5. So that's the limit of the speed. So the actual velocity is this. That's the magnitude. The magnitude of the velocity is 2.5, which means and also there's another thing. Yeah. So there's another thing to take into account, and that is that the starship accelerates and then it gets to the max speed. So this check is not accurate. It should also only check if the magnitude is equal to the limit, to the thrust limit. So when it gets to the thrust limit, then it reached the maximum speed. Okay, so that's what I want to be checking. So now I have to check census dot velocity dot magnitude is, I don't know, I'm going to say higher or equal to thrust limit. So only at that point yeah, and you know what, I'm going to have like another variable. Yeah, so this is what I'm going to do. I'm going to have another thing. It's going to be a float, and this is going to be distance, and here I'm going to say yeah, it's going to be start pause and then end pause. So here start pause is going to be census dot position dot x, and then end pause is going to be also that, and and I'm going to set it if seconds is higher or equal to 10. So after 10 seconds, I'm going to set the end position. So then what I'm going to do basically is just say, okay, so when we reach the maximum velocity, so the actual velocity, we are going to have like a start position, okay, and I'm also going to say, I'm also going to round this down. This is going to be an int, and I'm going to floor this, floor to end. It should be consistent. Well, now let's try this just using float. Now what's going to happen is that when we start moving, the start position is going to change all the time until we get the maximum velocity, and then it's going to start counting the seconds, and when seconds get to 10, then it's going to print the end position. Well, it's not going to print it, but it's going to save it. In fact, I should, yeah, whatever. So yeah, and those values should basically be set in this case it's going to be set every frame until we get here to the max thrust velocity. So then it's going to stop, and then it's going to get fixed at one value, and then the same is going to happen to end position. That's what I think is going to happen. I'm going to try to not be like so complicated about this. Shouldn't be so hard, but we're going to try this. This is yeah, let's see. So start position is -22 right now. I couldn't manage to follow it. Yeah, I'm a bit confusing right now because I'm not explaining myself properly. So yeah, I'm going to move this guy to the position 0, 0. So now here you can see that start pause is 0 and end pause is 0. So when I start accelerating, start position is going to change until we get to the maximum velocity. So then start position is going to be to remain the same value it was just the frame before we got to the maximum velocity. And then after 10 seconds, I think 10 seconds is a lot, but whatever. After 10 seconds, end position is going to be set to. What is the goal of having a stop position? It's not a stop position, it's just like I'm going to measure how much distance I can travel within a set amount of time. That's everything I'm doing. So let's check this, if this works. So it's not working. What the hell? Yeah, I don't know what's happening. It's not working. So senses.velocity.magnitude. I don't know what's happening. I don't know. Let's I don't know. Let's log this because I don't know what's happening with the magnitude. It should be getting to this value, which is 2.5. I think I'm doing this more complicated than it needs to be, but I don't know. I can't think of another easy solution right now. There might be another easy solution for this, but I'm too dumb for that. So yeah. What's happening here? So what's the value now? Okay, so it never gets to that value. It gets to like 2.4999997, which doesn't make a lot of sense. So yeah, let's say minus 0.1. Welcome to float. Yeah, exactly. Happens all the time. You cannot be checking for like exact loading values because they are never going to be exact. You have to use thresholds all the time. So yeah. So let's see now. Start position is 21.5. Now seconds, when seconds get to 10, like 10 seconds after, end position is going to be set. Okay. So okay, so let's try again. I'm going to set this to 0, 0, and also this ship is going to be 0, 0. Okay, I'm going to normal freeze. Now I'm going to set it to 0 again, and we're going to check this again, but from like a better reference point. Okay, so now let's see. Start position is 2.8, and then after 10 seconds end position is going to be set again. And yeah, I don't think you're going to be able to... Oh yeah, I released the... I have to do this again. Because I forgot what the value was. I'm gonna have to do this again. Start position 2.9. Okay, 2.9. Okay, and end position is 26.3. So if I say 26.3 minus 2.9, that gives me the exact distance that I traveled in 10 seconds. Okay, so in fact I could use another variable for that. Okay, so distance traveled, and actually I'm going to set the seconds to I'm going to call it test because I don't know. So test is going to be the test time, and here I'm going to say distance travel is going to be equal to end pause minus start pause. That's basically the difference between those two, is going to be the distance we traveled. And this should be consistent. So yeah. Yeah, okay. So actually I'm going to also comment this so that it doesn't set like a random position every time. Then also divided by 10 seconds elapsed time. Should I do that? Oh yeah. So yeah, that's going to be the final velocity. So that's going to be the real velocity value. Didn't you want the actual speed? Yeah, in reality, I want to know like how many units I travel in a set amount of time. That's what I want to know. This is the distance traveled is what I want to know. But I also want to know the real velocity value, which is going to be distance traveled divided by test, which test is basically the time, and velocity is distance over time. So this is basically going to say, okay, the real velocity is this. So now we can set different times and we can check like the actual velocity thing. And I can also go here and change max thrust. Well, I don't know if I can do that, but whatever. Test is going to be 5 for now. Okay, or maybe 1, just 1. I'm going to check this for 1 second. I'm going to hit play. I'm overcomplicating myself, but it's fine. It's the process, and I like the process. So start position, then end position. Okay, so real velocity. What the hell? What? Why is real velocity value the exact value of distance traveled? What am I doing wrong? What the hell? Oh yeah, I'm so dumb because this is 1. Oh my god. Oh man, I have to get good at basic math. So yeah, it makes sense because like if I travel 10 units in 1 second, that's the velocity. So yeah. Okay. Okay. So velocity is 10. Something like to respond to you yes or no, I will need to test the value of yes and no first. So are you thinking I should do something like that to test? So yeah. So 1.8, that's the actual velocity, and it should be consistent every time. Yeah, it's sort of consistent. 1.6. .2 is not consistent at all. And maybe it is because I'm checking this in the update instead of the fixed update. No, I mean you got your numbers. Are you bound to bound by frame rate? Yeah, that's the thing. I'm doing this in the update, which is bound by the frame rate, but in reality in Unity there's the fixed update, which is the delta of the fixed update, which is the difference between each frame, like the time that passes between each frame is fixed. So I think I should do it here. I think could be that start position is getting reset too. Like it is being reset, but it's being reset once I release the button, so it shouldn't matter, I think. So let me check this in the fixed update because it should be more consistent there. So let's see. So let's see right now. Test is 1. Okay, so start pause is 2.9. Okay, so 2.48. That's the distance traveled in 1 second. Now, if I start again, it should be the same again. So let's see. No, it's not the same. Yeah, I'm not sure. I must be doing something really wrong. Like, so maybe this doesn't make any sense. So I can just remove this, and there should be like, you know what? Maybe the best thing would be to just check the Unity documentation. Maybe that's the thing. Rigid body dot velocity. Velocity. Okay, you should not modify the velocity directly, as this can result in unrealistic behavior. Blah blah blah. Okay, so there's nothing here. I don't know. I don't really know. I think. So the numbers are there because I know that the maximum velocity is going to be this divided by 2. which is 2.5. The thing is, I don't know if that represents the actual units you're traveling every second. I don't know if they're using seconds or like minutes. I don't know. It should be seconds, but I don't really know. So yeah. I'm going to hit play here and just check something, like just by eye. So I'm just going to press this. Okay. I don't know, man. I want to try again something simpler, so maybe let's see something. Float time, load distance. Input.action.jumping. Okay, and here I would say so this is pretty straightforward. I'm going to just press the thrusting button, and when I press that, the ship is going to start moving, okay? After 10 seconds, this is going to tell me, that's the thing. I should be checking that's so annoying, man. That's really annoying because we have acceleration and yeah, I think this is what I'm going to do. Yeah, that's what I'm going to do, basically. And I'm going to do it but after 5 seconds, so I don't have to wait 10 seconds every time. But here I'm going to say again, senses.velocity.magnitude is higher or equal to thrust limit minus math.epsilon. This math.epsilon is basically a tiny, you can see there, tiny floating point value. You don't even need it. But why is that? Why do you think I don't need it? Just keep the racing speed, okay? Okay. I'm going to keep the racing speed. Keep racing the speed. Okay. So the speed, the thing is, I'm not limiting the speed. The speed is already being like, the ship accelerates, and when it gets to a certain speed, it stops there. So it reaches a max speed at some point, and that's the maximum speed it's going to move. That's the thing. But I don't know, let's see. I'm just going to start moving like this, and after 5 seconds, it's going to print something here. Okay, distance traveled, 10.94, blah, blah, blah. Okay, the second time it prints, it is going to be at maximum speed. You know what? You're correct. And actually, the actual distance is not like the position. It should save the last position and calculate the last position, like the actual position minus the last position, so that we know the distance. Well, we could just do it mentally. But yeah, let's do that. You're a lot more practical than I am. I'm so complicated sometimes. So yeah, now it's 10.9, so it is consistent. So now it's 23.4. So basically now what I need to check is the difference between all of the consecutive logs, okay? So yeah. Yeah, this was a lot more practical, but I'm so dumb. Whatever. Okay, so now this is a lot more consistent. Now I should be able to say 85 minus 85.9 minus 73.4 is 12.5. Okay, and 73.4 minus 60.9 is also 12.5. Okay. So basically that's the distance we travel after 5 seconds. Okay. So if we use like the simple formula, I don't know what it's called in English. Exactly, 2.5 multiplied by second. Oh yeah, so that's correct. That's basically, so 2.5 multiplied by 5 is 12.5. So 2.5 is going to be basically the velocity, which is per second. Okay, so now I confirmed that. Okay, perfect. So now now this is great, because now I can now I know that if we go in the normal speed, which is 2.5 ish, we're going to get to 48 after whatever amount of seconds, which is the actual position of this planet. And the idea is that you get the idea is that you have to move with hyperspeed between planets, because otherwise it's going to be really slow. So let's say so hyperspeed is 200, okay, and the actual speed here is going to be 100 because it's divided by 2. Okay, true, it's finally true. Yeah, finally. So yeah, I have to get better at like this kind of math, because it's really basic. Like, I know how it works and I can manage my way through it, but you see, like, I already spent like, I don't know, maybe 40 minutes on this. It's really dumb to spend that much time on this simple thing. It should have been really trivial, but yeah. Anyways, that's fine. I'm not trying to torture myself with this, but okay, anyways, we got there. That's the important thing. So now I know that for example, this is max hyperspeed, and I know that the actual velocity is going to be half this, which is 100, okay? That's what I think. So if we say after 1 second we can travel 100 units in hyperspeed, that means that if I want the player to be from the center of the if I want the player to be what's the word? I want the player to go to a planet that's in the furthest orbit, and I want the player to get there after 30 seconds. That's like the time I want it to take. Okay. So for that, I would basically need to set the planet at it would be like 3000, I think. So it's going to be 100 multiplied by 30, which is 3000. That's correct. Okay, makes sense. Okay. So then, if I divide 30 by 4, what do I get? 7.5. So 7.5 multiplied by 100 is going to be 750. So that's the first orbit basically, and I want to, for now, I want to basically distribute the planets in like an equal amount of distance. So that's going to be 700 units each. So the first orbit is going to be 750 units, like the first radius, okay? And then the second is going to be 1500, and then the third, not that. It's going to be at 2,250, and then the final one is going to be at 3,000. So that's basically the idea. Now I can set that as the ratio, as the radius. That's what I'm talking about, the radius. So basically, let me go here and just do a little drawing. So in order to position the actual planets in the space, I'm going to make it square, because the velocity of the starship doesn't change depending on the angle. It's always the same speed. It should be different when you go in that direction because of the, well, I don't know if it should be different. The thing that should be different is the rate of movement of each thing in the background, because of the perspective, but I'm not going to bother with that because it doesn't matter really. What matters is that I have like a set value for each orbit radius, okay? And basically the radius for this is going to be 750. Then the radius for this is going to be 1500. Then for the next one is going to be 2,250. That's the number. I can't properly say numbers in English, it seems like. And then the next one is going to be 3K, basically. So those are the radius for all of the positions. Okay, so now I need a couple things, okay? So now let me go to definition planet, and now in basic planet properties, I'm going to add the actual orbit. Okay, the actual orbit of the planet is going to be defined by itself. So yeah. Well, no, it shouldn't be defined by itself. I think it should be defined by the thing that creates the planet, which is the okay, which is the star. So now here, basic properties. Well, I have star seed, planet index. Am I using planet index somewhere? Where am I using it? Yeah, I don't think I'm using it anymore. So, oh yeah, I do have an orbit thing here, and it's being set randomly, which is not great. So I should remove this and also this. Okay, space position. This is also, yeah. I'm just going to remove all of this because it's not going to be used anymore. And here, instead of passing the planet index, I should pass the orbit where the planet is. So now I can pass through the orbit thing, okay? And now for this, I'm just going to comment all of this again, because like, I'm not going to be creating a planet using a preset right now, okay? I can do that later, after I have all of the system properly creating the things and setting them where they need to be. So, okay, so here, now basic properties is going to be created here, orbit, blah blah blah. Okay. Okay. Okay, yeah, there's a lot of refactoring I have to do here, but the base is there, which is good, which is really good. So, where am I defining the planet? I think I'm doing it here, and I think I'm doing it in here, planetary system properties. Yeah, I'm creating this and I'm setting the actual orbit with this, which is not bad. I think it's fine. I think it's fine. Let me think about this, because depending on which orbit the planet is in, is going to be like, if I leave it like this, the thing that's going to happen is that every time, if there's like a star that contains only one planet, that planet is always going to have to be in the first orbit, always. And I don't know if I want that. I want the planets to be like, maybe there's just one planet and that planet is in like any orbit. It could be in any orbit. So maybe I should like create a list. Yeah. So I should basically create a list of orbits, and now I can say 1, 2, 3, and 4. Why is it not working? Should I do this? Yeah, that works. And now I can say just orbits.shuffle. This is a library I have for shuffling lists. So this list is going to get randomized, okay? And then I can just say orbits I, okay? And then if this has like 2 planets, then maybe the first 2 indices of the orbits indices is like 3 and 2. And then those are the orbits that are going to be set for the planets, and that's it. Okay, that's amazing. So that should work. Oh yeah, I should remove this. Now that I tested everything and everything is working perfectly and blah blah blah, and I know the exact distances I need and all of that thing. So yeah, I think here I should do some like a method called, I'll be right back. Need to do something. Hey! Ha! You're really close. Really, really close. Is this it? I don't think so. Yeah, there's too much delay. Yeah. I should maybe make the ball a lot more slower. I don't know. Or maybe try to reduce the delay on Twitch. Yeah, there's a lot of delay. It's really hard. You're using low latency, yeah, but I don't know if I have set the actual Twitch thing where it I don't know. You know, the really low latency setting. I have it in the standard one, which is, it should be already low, but I don't know. But yeah, anyways, I can play if you want. I can. 1.5 seconds. It's more than that. Maybe this is it? Yeah, we won. Let's go. Okay. So, okay. Let's go. So, let's see. What was I doing here? Yeah, define planets. And what the hell? So planets count. Okay, and then I can do this a bit cleaner. Planets count. Okay. Okay, perfect. Now I can also comment this because this is for preset. So whatever. I'm just going to comment this. And what else do I want to do? Oh, give me one moment. Okay. Okay. So back to this. Now I'm properly defining the actual orbits of the planets. Okay, randomly, as it should be. Okay, that's perfect. So I'm shuffling this. Oh. So this is not. This shuffle thing is not using the mer thing, so I should fix this. Okay, so this is not good because it's not using this system. It's just like, in fact, it's using random range here. So, well, I could. I could use, I could create a version that does that. So this list T array, yeah, I'm going to use the same thing. I'm going to do the same thing, but in this case, instead of using random range, I'm going to say lemur, the next int. That's it. It was as easy as that. So yeah, I don't need to fix anything. I just need to pass in the lemur. That's it. It was really easy. So yeah, now we're talking. Perfect. Okay. So so now planets are going to have orbits, and now I can go here and I can go to planetary system here, and this number is nothing. So now I can have constant, the same thing you said to me just a while ago, that I should define constants for the actual radiuses of the orbits. Okay, so this is orbit 1 radius is going to be 750. Okay. Well, it's always going to be 750, I think. So you already calculate orbit for the minimap. Where is it? No. So the minimap is not using actual like orbit calculations. That's like mostly like hard-coded. The only thing I'm representing in the minimap is just the position of the planet in the orbit. But the orbit itself is just a representation of like orbit 1, orbit 2, orbit 3. I'm not using any calculations there. I'm just setting the position in the orbit, and that's it. But then where I'm actually going to use this radius is in the actual world space, where I set the position of the planets. And that's basically I think orbit base radius, and then I have to multiply this by the orbit. So my fault. I meant you already calculate the positions in minimap. Yeah, of course. So I'm using here a base radius. So this radius is just to multiply the position of the planet. So for example, if I say the planet is in a position of 0.5 in the orbit, which means that the planet is going to be so remember that the orbit is the position in orbit is a percent, being 0 this, and all the way around is 1 again, being this 0.5. Okay, so this is halfway, and then halfway again back to 0. Now I have to convert this to actual world positions, and to do that I will use the formula you sent me for the ellipsis. But also I have to set like an actual radius for this, so that I know the like how big the orbits are basically. And the thing is, in the actual scene, the orbits are not going to be elliptical, they are going to be perfectly circular. Okay, that's because it's something convenient for me and for how it works, because when the ship goes upwards, the speed is not lower than when it goes like this. and that's because of how the parallax system works, that it doesn't make like a distinction between X and Y axis. Well, I have something for that, but it's not making a distinction on that. So basically, the planets are going to be positioned as if you were seeing the orbits straight down instead of in a perspective like this. This is looking like we're not looking straight down, we're looking like with a perspective, with an angle. So in reality, what's going to happen in the scene is that we're going to calculate everything as if the orbits are being seen from the top down, basically. And that means that I can use like perfect circle calculations for the radius and all that kind of thing. And I don't need to do extra calculations for the actual size of the ellipses and blah, blah, blah. Okay, so what I'm going to do, they will screw. Why is that? What do you mean by that? So let me show you really quick what I'm going to do. Let me show you really quick. Because the minimap will show a thing, the planets will be somewhere else. Well, you might be right. Well, in reality, what I'm going to do with the minimap is just use this aspect ratio to actually know. Wait until this finishes loading. So you can see here, like the orbits here are in a perspective. They are not perfectly circular, so the radius here is like different. They have like the mean axis and the I don't know the name, but you know what I'm talking about. And this is not going to represent exactly the position of the starship, but I'm going to calculate something extra just for the minimap, so that the minimap represent accurately the position of the starship and the planets. I think it's going to work. So yeah. In any case, first I want to code this so that it works in like a normal context, and then I will see if I need to do extra calculations and all that crap. So yeah, for now I think this is fine, mostly fine. And then when I set the actual position of the planet sprite, well, there's the thing, in the planetary system, yeah, so here I should have like a reference to 4 different planets. So this is planet, so this is a namespace, so this doesn't work. Now what is this? Is this the actual... No. Oh yeah, it is. Solar cycle, land. Oh yeah, no, it's not this. Planet sprite, I think it is. Yeah. So this has the all of the properties of the sprite. Okay. And I should be setting the properties there. I don't have a lot of time left, but we're going to try it we're going to try to do something here. So this is a celestial object planet. Okay, what the hell? Oh yeah. I should be using this thing. Now set planet shader. Okay. So what's happening here? Background object, set planet. What the hell? What's this? Planet. So background, why is background object, why does it have like a, that's weird. Oh, I know why it has that, because planet is another class. Oh yeah, I'm confusing terms here, but basically so this, yeah, this should have planet properties. So here I should have like a I should rename this class. I'm not going to do that right now because it's going to break a lot of things, but should rename that class to planet system because, yeah. Anyways, and in fact, this one should also be called something like planetary system manager or something like that. Okay. But anyways, doesn't matter. Here I'm going to have to set planet properties equals to planet properties. Okay, and then here when I say init, I should say set planet shader. Okay, and this is really not the best organized, but it doesn't matter. So let's say right now planet shader. So for this I need to have the celestial object, background object. I have the renderer and use pixelator bake. Okay. Okay, so this should work. And now I want to see how am I using, how I was doing the actual setting of the thing, utilities. Oh my god. So I have a thing here, planet sprite generation, generate sprite. And where am I using this? Generate sprite. Okay. So shader properties, get color, next in, next float, apply shader properties. Okay, this is what I need to do to use. Get planet size is length. Okay, so this was being used somewhere, I don't know where, I don't remember, but this is what I want to do, what I want to use. So basically here I need to say utilities.generators.planet sprite generator.apply shader properties to the rend, and the shader properties are going to be planet properties.shader basic properties of shader sprite shader. Is that correct? Yeah, it seems like it is. Okay, great. So now here I shouldn't have this. This should be celestial object underscore planet. And now after creating this thing, I should create planet sprites. So for planets.length, I'm going to say planets I dot set planet properties, and this is going to be oh, so yeah, I should do this. If I is less than planetary system properties dot planets count, planets I, going to activate it, true. Then I'm going to set the planet properties. Now, do I have like a set position thing or something like that? Background object. Yeah, I should have like... I should do transfer dot position equals new vector 3 position dot x position dot y. In fact, I could do transfer dot position equals position. I think, yeah, that's much easier. So that's great. And now I can close this. I can also close this maybe, and this. I'm going to be opening things as I need them. But now, set planet properties is going to be the planets I, okay, and then I'm going to say planets.init, and that's it. Well, that's not it. This should be planets. I should do the thing now. So now is the moment where I'm going to actually use the set the radius thing and blah blah blah. So planets index I dot set position and position in orbit. So what the hell is this? Okay, so basically so how should I do this? Okay, there's a lot of things I have to calculate for this. So I need to say float orbit radius is going to be tables dot planetary system dot orbit base radius multiplied by the planet orbit, okay, dot basic properties dot orbit. Okay, there's that's one thing. Then I need to set the position, which is going to be done by doing this. Is going to be utilities.helpers dot get a position in ellipse. Okay, ellipse center is going to be vector 2.0. Semi-major axis is going to be orbit radius, and also the minor axis is going to be orbit radius because it's going to be perfectly symmetrical. Okay, and T is going to be the position in orbit. Okay, and yeah, I think I should save that in a variable so that this is not so long. So planet pose in orbit. In fact, I'm going to say percent so that I know that this is the value that goes between 0 and 1. But so now we have that, okay? But now we have to reduce this by actually the position relative to the background plane. So how do I get that number? So planet position. So this should already work, but I also need to do something else, which is basically setting the position relative to the background plane. Okay, so how do I get that? Time to go to bed for me. Okay. Have a good one. Good night. See you tomorrow. I don't know if I'm going to stream tomorrow, but I will be live on Wednesday. So if you're around on Wednesday, then see you on Wednesday. Okay? Thank you very much for watching and for staying here and for helping as always. Thank you very much. Okay, good night and have a good sleep. So, I'm also going to finish the stream soon, so I'm going to do one more thing and I'm going to test it, and whatever it works or not, I'm just going to end the stream because I have to do some things. So yeah, anyways, now okay, so let's try. I think what I should do is basically divide the actual position by the relative multiplier. So if 4 multiplied by 12 is 48, then 48 divided by 12 should be 4. Okay, so I should do basically the opposite thing, which is planet position. Okay, I can do that. So I can divide it by. Now, how the hell? Oh yeah. So I do know which background plane it is. Okay, so where is this? Okay, BG7 relative multiplier. So for this, I should basically load get so here I basically need what I need to do is basically say background planes plane, and that's it. So now I'm basically going to return an int of plane divided by 2. Now, why is this not working? Cannot declare instance member in a static class. Can I do static? Okay, it seems like I can. So basically what I need is to say tables dot universe dot get background plane multiplier, and here I should be able to access the actual thing by saying planets I dot background plane background plane. So layer index. Oh, it's called C layer. Why is it called C layer? It's so dumb. So yeah, whatever. C layer. Oh, and it's not public. So yeah, it should be public. Okay, and now I can say C layer, and that should be it. Well, it doesn't work. So why is this not working? Because the planet does not contain a definition for Z layer, and no accessible method extension method Z layer accepting a first argument of type celestial. Oh, What the hell, man? This is celestial object, which is also a background object. So why is this not? Oh. Oh. So it seems like I'm not setting the actual thing. So yeah, let's yeah, it's not background plane. It should be called background planes. Where's that defined? Okay, so universe.background planes. And this shouldn't be plain, this should be plain. So this should be set by the thing that initializes it. And this is going to be basically, oh yeah, it's everywhere. So planetary system, it needs initialize it. And background plane also initialize this. So for now, I'm just going to hard code it, and I'm going to say, yeah, because this is not correct. So background plane. Yeah, it would be great if I could actually set this. So yeah, I'm going to set it because I need to. Public. I'm going to make it a property so I can access this. Okay, that's perfect. And now I can do this. And I can say background plane equals background plane. Okay. Now, yeah, that's perfect. And now here I can say background plane. Perfect. Now celestial object is going to complain. Okay, that's perfect. I can do this here. Okay, great. I have to also do this here. Okay, perfect. Init. Oh yeah, I shouldn't be initializing this here because it is going to be initialized in the background plane thing. And what's initializing this? Land system. Okay, so here I should have a reference to that. So background planes. Yeah, here I shouldn't be initializing this there. I should initialize the background planes. So for here, I should basically initialize background planes dot length, and here is going to be background planes I dot init. Now, yeah, so here I should be setting Z layer. Okay, that's perfect. Okay. That's amazing. Now, I need to see if I'm doing anything else. Set planet. Okay, but I'm not going to use the planet. So I think this should be correct. Oh, but the background plane is set afterwards. That's annoying. Well, anyways, I'm going to do this here, and I'm going to remove this, And after we set the planet properties, I'm going to do the other thing, which is set planet shader. So yeah, set planet shader. Instead of doing it here, whatever, I'm not going to do it there. So yeah, now this should work. It could go terribly wrong. Well, this should also have the... Well, I could basically just remove this here. That's much easier than having to write everything again. So yeah. Anyways, oh yeah, I was receiving a lot of messages. Okay, so here, so basically background planes, planetary system should have a reference to all of the planes. Okay, so background planes, and then I should also have a reference to all of the planets. So so yeah, I should have 4, of course. I can remove this, and I'm going to no, I shouldn't. I should do this and this. Planets. Okay. So now let's see what happens. I'm going to hit play, and let's see. It shouldn't be like broken, but it can happen. Okay, it didn't break. That's surprising. Now this constellation has 2, so those 2 planets, this star has 2 planets, so they should be, yeah, that's correct actually. That's actually correct. And those are, in which orbits are they? Oh yeah, this is not representing the actual orbits they are in. So I should basically go to UI orbits handler, and I should disable all of them, and then I should do this for the actual orbits. Yeah, I should do this. So now for the actual planets, so for planets that count, I should do this, and I should do if I equals planets I dot orbit dot basic property dot orbit, then I do this. Yeah, I think that's it. So let's check now. It should work. Actually, that's the first time that a 2-planet star was created. That's funny. That's really fun. So let's see. Okay. This one only has 1 planet, and the planet is actually, well, this is broken, I think. This is broken. So where actually are the planets? Okay, there's 1 planet. Now this one, where is this? There, there, and there. Okay, this is really weird. So okay, so I'm not even able to see them. Yeah, because they're so distant. But like, what happened to the minimap? It's really weird. What happened to the minimap? Let's see, maybe this is not great. Um, it should be working, but I don't know what's happening. So let's hit play again. So planet, there are two now, but there's just one here, down here. So why can't I see the actual planet properties? Where's the basic properties? Okay. Why is this like... Okay, whatever. Orbit is number 3. For this one is number 1. But the actual UI orbits are like 2 is the only one that's activated, so what? That's really weird. Really weird. So why is that the case? Yeah, I don't know what's happening here. It's really weird. So this is only going planets, the basic properties. Which kind of planets am I passing through? UI orbits planet. Okay, so maybe the data that's here is not the same. Planets are 2. Yeah, that's correct. Orbit is number 3. And here is number 1, so that's correct. Yeah, I don't actually know what's happening. Oh, I think I know what's happening. I'm using I as the index for... Yeah, I'm so dumb. I shouldn't do this. This is really straightforward. I should only do like this. So it's int orbit index equals this, and now it should be orbit index. It was really simple. So yeah, now it's going to be accurate. Should be accurate in any case. Let's hit play now and let's see. So now it should correspond to the actual orbits to the actual planets. Okay, no, it's not working. So what's happening? Oh yeah, it's -1. -1, that was the issue. Okay, that makes sense now. So if I hit play, let's see what happens. Okay, perfect. So now they are so now I think they do. Okay, let's see. Background planes. Now, they are so far away, it doesn't make any sense. So let's set this to, okay, 249. Okay, so yeah, they are actually representing the thing that's in the actual thing. So I think that's correct. I think they are being correctly positioned in the space. So now I should be able to grab to like, oh yeah, and also let me go here and uncomment this, and oh yeah, let me just set it to whatever, and let me also go to the idle state of the starship and remove this angle thing, because it should be always in the isometric angle already. In fact, I think it should be in 45, so it should be 45 in fact. Or maybe, no, yeah, I know what I should do. So it should be isometric angle. Where's the get total frames? So I should do, and what's the thing I'm doing with total frames? 360 divided by total frames. So that's what I should do, plus this divided by, no, 360 divided by that, and divided by 2, I think. Whoa. Okay, maybe that would work. Anyways. Okay, let's hit play here. And I should be going soon. So now the angle of the starship is correct. Okay, perfect. Okay, great. So this is actually working, and if I were to let me just focus in the starship, and now let me just grab one of the planets, the one that's closer. I think this one is the closest one. Yeah, this is accurate actually. Now it should take me actually like something like let me just focus this again, and I should do this. Okay, now if I were to move towards that planet, I should be able to reach it like in about, yeah, in about 7 seconds or so. Okay, and I reached the planet, actually reached the planet. Okay, it worked. That's amazing. That's amazing. That's completely amazing. So that's so cool. So now I have basically the system for traveling between planets, and now the thing that's remaining is basically just setting the actual position of the starship here in the thing. Okay, that's the idea. And for that, I think I need to do some calculations, but basically that's the next step basically, and that's that's what we have actually in the current step here, which is track player's position. And yeah, that's all it took for us to actually be able to do that. Now that we have all of this, the positions of the planets actually relating to where they actually are, So now we are able to do this easily. So that's amazing. Okay, so now there's one thing, and that's the like yeah, every planet looks the same, and I don't know why, and I don't know why that's the case. Now the good thing is that they are actually pixelated. That's great, but I don't know why they have the same properties in the material. So yeah, I have no idea, but they all look exactly the same, and that's a bit weird. So yeah. Anyways, that's something we need to fix later. So yeah, that's going to be the stream for today. Okay. Okay, I'm going to push this to fork later, but now I'm going to end the stream. So that's the stream. Okay, thank you very much everyone for watching, for chatting, for staying here, for anything, for helping as always. Okay, thank you very much, and don't forget to join the Discord. Okay, so you can get notified when I go live. Okay, I stream like 3-4 times a week, and yeah, so if you don't want to miss the streams, just be sure to join the Discord and you will get notified whenever I go live. Okay, that's great. And also if you want to join to share art or anything, you can also share your stuff there in the Discord. Okay, that's the idea, so we can grow a community and everyone can share their thing. Okay, that's the idea. So other than that, that's going to be the stream, and again, thank you very much, and I will see you in the next one. Okay, thank you.